what I was wanting to do today was to work out where we are on the screen and then try and allocate materials to the character. I think that's what you call it. Now, how do we turn that on? How do we turn it on? Good question, John. It's this, isn't it? Ah, there we go. Right, okay, got it. So, what we can do is, we can, from what I understand, is we have got 16 material types here, and we can assign either a tile or a character a material type. Now, a material type can mean anything. So we could have one that means it's an empty space, that he'll just fall down, done. One to say it's floor, one to say it's a wall, one to say it's a ladder, and stuff like that. So we can start getting the Hunchback character to interact with its surroundings. But at the moment, you see, we're not. We've got him on a specific level, and he goes backwards and forwards. Yeah. So what we need to do is first, where is he? Yeah, where is he? Then figure out what character is on. Well, the thing is, we need to figure out what character's underneath him and either side of him. So, because we need to, that if he's walking along here, then bang, if he hits that, it's a wall, can't go through it, can't go up, can't go through it. But this ladder, it could go through, but it would have a characteristic that said he could go up. So we need to figure out a system to identify his surroundings so we know what to do. And that's going to be a tricky thing. I've not done this before, so yeah. So first we've got to figure out where we are. Where is he right now? What character is he on? And then we can figure out what's going to happen. So we need to write a routine and get started on basically doing the collisions. So let's create another file. Let's create another file, lib do the standard stuff. Oh, we might as well do the name spacing bit. So we need a routine to work out. We need a routine that takes the XY where they are now, and then spits out the character XY. Just thinking, character or the stage. No, the stage is a set of tiles, isn't it? So it'd have to be a screen. Alright, mate. I'll see you. I might see you later then. Alright, take care. So we need to work out screen location. There we go. That'll do. And so input params. So X can be X low. Accumulator can be X high. And the Y can be Y. I'm just wondering if it'd be would it be easier to send in the sprite number and work it out, or we get the sprite? Might be easier for... Let me just... Where's sprites? Hi, Stacey. I suppose we could use this. Yeah. No, we're not going to do that. We're going to say x equals the sprite number. Because if we send in the sprite number, then we can get the, as we saw there, the screen X and the Y. So we don't need to... Let's have a look. Yeah, that'd do it. That'd do it. So we're going to go Y equals the sprite number. So so let's do the first one. That one. But Y gets destroyed, doesn't it? Yeah. So we're going to have to store that here. So we get... Yeah, so... Well, I don't think we can use temporary variables there, can we? Okay. Let's store Y there. So we're storing Y because we're going to destroy it. So we get screen X from here, and it comes back, and so we need to store it here. Right, let's LDA hash. So this one can be X high. And then LDA X low. You'll see what I'm going to be doing in a bit. Right, because I know that when I do get Y, we will destroy some... Yeah, we destroy the accumulator. So let's do that. So LDY, JSR, that. So what does that go? Accumulator is the Y variable. Okay. Right. In fact, we'll do that. Right. Because we are destroying registers when we run these routines, we've got a way to store them. So we're going to do some self-mod code, which basically says we're going to store away the sprite number and we're going to store it there. We are going to when the result of this we're going to store in x high and x low, and the y. In fact, is that? I spelled that right. That doesn't look right at all, but that goes there. So we're saving the states once we come out of the routine, because these two, like I say, that destroys accumulator and this destroys all of them from what I saw. Yes, destroys them all. So we need to keep them. We need to keep them. Keep them intact. Now we've got the point. Now we've got the point on the screen where the sprite is. We should be able to try and work out where. We should be able to try and work out where the screen location is. So, so if you think about it, we have to divide everything by 8. Yes, we have to divide everything by 8 because it's 8 and 8. So we'll work out the x first. So we load the accumulator with the high, so it could either be 0 or 1, yeah? Oh, I suppose we better put a test in there. Because if it's off the screen, we don't want to do anything. Well, we'll come to that later. Let's make a note of this. Right, so it's either 0 or 1 xi, and to make sure that we divide by it properly, we need to set the carry. So if it's 0, carry's clear. 1, the carry's set. And there's an easy way of doing that, and that's to roll. So we need to clear the carry to start with, load whatever it is, and roll it into the carry. So this hang on, are we rolling right or left? Hang on. So if it's 1, it's on this side, so we need to rotate right. That's it. So what that's doing is, if it's that, it's going to rotate it right that way, which means that the accumulator, because we've cleared the carry here, which will mean everything will get shuffled across. So if we, let's just do this. So the bracket 0 is the carry flag, yeah? So as soon as we rotate right, the carry would come into the most significant bit. So 1, 2, 3, 4, 1, 2, 3, 4, and then the carry would be 1. Yeah? But if this is 0, then all of this is 0, so it just stays 0. So that's a way to set, a quick way to set the carry. And then you divide by 8. So we're going to logically shift right, so that's divided by 2. Evening, Andy. Right, so this is divide by 2. LSR, so this is going to be divide by 4. Divide by 8. So the accumulator now should have, so we're doing the X, so the accumulator should now have the column. So let's put something here and screen column, and we'll store, after this we will store it in screen column. The only reason to do that, we're doing that, is because that's it. That's what we need to do. Forgot that bit. And the only reason we're storing it in string, you already ROR'd once. Does not that divide by 2? No, because the whole point of this is to set up the carry, yeah? So the accumulator will either be 0 or 1, yeah? Because that's what sprite X will be. Hence this question here, because we're working out the delta, yeah? So if the sprite is too far right, then the X high is going to be 2, 3, 4, blah 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 blah, yeah? Or if it's the sprite is too far left, it's going to be 255, 254, 253. This is why I've put this question in. What happens when the sprite is off the screen? We need to do something to say if the sprite's off the screen, we don't need to do any calculations, yeah? And in fact, I'm going to do that so we can search for the to-dos. So let's assume in an ideal world all the sprites are on the screen, yeah? So we load, so we've got their X and Y altered coordinates. So these are the X and Y on the screen, the delta ones, yeah? So this should either be 0 or 1 in an ideal world, remember? We're hypothetically in an ideal world. This is 0 or 1, so that means the carry will either be 0 or 1, because that's what the rotate right does. You know, if it's 1, it rotates that 1 bit into the carry. If it's 0, as in the XI 0, the carry's already clear because we've already set it, so it'll always be 0. Then we load sprite low, divide that by 8, which will divide, which will not divide. Which will not divide, because we need to do this first. And the reason for that is because we need the carry to be put into bit 8. Right, so we need to rotate right anyway, because the carry needs to be imported into the byte. Now, logically shift right doesn't do that. It just puts a 0 into the high byte, and then the high bit, the low bit gets put into the carry. We need to put the carry into the byte, so we need to rotate it. And then we can do LSRs to finish off the divide by 8. That's all right, mate. That's all right. I'm trying to explain what it is. So, if we've got 2 bytes, yeah? And let's say it's this. Alright, so these are the 2 bytes. So we'll put a terminator so you can tell the difference, right? This is going to load that into the accumulator. So in the accumulator we end up with 1, 2, 3, 4 space 1, 2, 3, like that. We're going to rotate it right, and because we've cleared the carry, so I'm going to put the carry status in brackets, yeah? So we've cleared the carry, then we rotate right, which takes that number, and we end up with that result. So we end up with 1, 2, 3, 4, 1, 2, 3, 4, but the carry has a 1 in it. Then we load X low, so the accumulator then, so it looks like this, so we're going to do this, and the carry is set to 1. In fact, no, we'll leave it like that. Then we're going to do the rotate. So after the rotate, we'll end up with 1010, 101, and the carry is set to 1. And the only reason that is because remember we've shifted right. So this 1 goes into the carry, and that 1 comes here. Yeah? So if I put the 1 there, which is in the carry, goes in there, and then the last bit goes into the carry. Now we're not bothered about the carry now. We're not bothered about it. Our first divide by 2's happened. So we have divided this number. So if I put the carry up front like that, we've divided the number 10101 divided by 2. Yeah, which becomes 10101 101. Then we do the logical shift right, which basically does this. 01, oops, 01, 01, 01, 01, like that. But we're not bothered about the carry anymore, even though the carry would be set to 0 because we just logically shifted that 0 into the carry. And then divide by 8 again. I'm trying to make it easy, trying to make it understandable. So we'll put another 0 in there, move that across. That goes into the carry, and we lose that. So we end up, after the finish, this is the screen column. Does that look right? 1, 2, 4, 8, 16, 32. So that's 32. Yeah, that's right. That's right. 32, 16 plus 8. No, that's too many, isn't it? No, that's 32. 1 to 8, 64, 32. That's, have I worked that out right? 32 plus 8. Yeah, it looks alright. Oh, maybe our start number was too big. That's probably too big. Yeah. But that's the whole concept, yeah? So we end up taking a 9-bit number. We end up taking a 9-bit number, dividing the whole lot by 8 to give us a screen location. Now, for the Y, it doesn't matter because we don't need to. So clear the carry because we don't want anything in it. LSR, LSR, LSR. Div by 2. Div by 4. Div by 8. So we're going to say X is that, and we're going to transfer A into Y. So we're saying, alright mate, talk to you in a bit. So our output parameters is X equals screen column and Y equals our screen row. So that's what we're going to return him back out. So let's put the A back to 0. So let's just make sure this looks right. So we've still got this outstanding issue here. And in fact, I'll make that a little bit more visible. There we go. So we get the X, we get the screen X, not the stage X, get the screen Y, and that gives us our row and column. Sort of, I think. I may be a bit wrong here, but we'll find out soon. So, once we've got our X and Y, we need to now work out exactly where it is on the screen, that X and Y. Does LSR always divide by 2? Yes. Let's work it out. Alright? So we'll make it nice and easy, yeah? So 1, 2, 3, 1, 2, 3. Okay? Nice and easy. So 128, 64, 32, 16. So that's 16, yeah? So we're going to logically shift it a bit across. Right? We're going to perform the LSR. So that would then mean, so that means that this one goes there and everything else shuffles across. So you end up like this. 1, 2, 3, 4. 1, 1, 2, 3. So we've logically shifted it right. So what's the number that we've got now? Yeah? We had 16 before. We've got 1, 2, 4, 8 now. So 16 and 8 is divided by 2. In binary, it's always multiply by 2 or divide by 2. When you shift the bits, so if we did an ASL, which is the other way, that's times in by 2. Yeah? No. Every question is not a dumb question. They are great questions. Yeah? This is the way we learn. But that's how an LSR works. Yeah? That's how an LSR works. Every bit gets shuffled down the order. And so effectively you are dividing by 2 because you're moving it from bit 5 to bit 4. So bit 5 is 16, bit 4 is 8. Alright? Right, so we need to convert this X and Y yeah, I suppose. Right, so we've worked out the screen location. Well, we've worked out the screen XY. Let's do that. Now, we need to work out the screen location. So, I can't remember. Did we have memory with screen locations in? I can't remember. I'm sure we did. Storage. It's got to be in storage if it's anywhere. Cheers, mate. Love you too. Right. We don't seem to have, unless it's in the map. Let me just have a look in the map. I know, mate, I know. Right. Ah, here we go. Here we go. Is it in here? Yes. Excellent. We can use these. Okay. Now that's a problem. Because we got 2 screens to look at. So we have to okay. We have to figure out which screen we're in. We have to figure out which screen we're in. So where's my scroller? Yeah. We just got to work out which screen we're on to make sure that we're... Now there is a test because I was using it in the scroller. I'm just going back to it to find out. Here we go. That's the test. That's what we're looking for. That. Right, so get screen location. So we're getting the screen actual location. So we've got we've worked out the XY. So our input parameters are x equals screen column, y equals screen row. Now because we're switching screens, yeah, we have to figure out whether we're on screen 1 or screen 2, which is that. So we load the current screen high. Is it screen 2? If it is, then work out on screen 2. If it's not, then it's screen 1, which is what we're here. So we've got Y and we've got X, so we need a 0 page location because we need to be able to put it somewhere. Just trying to think. Do we need to use a 0 page location? Yeah, we'll use one. Right, what have we got? Not there. Right, let's pick, not that one. Let's pick that one. So, so I've just made a label just to make it read right. So we're looking at screen 1. So the first thing we should do is get the row. Let's get the row first, because the row is going to be the biggest one. Yeah. So, load, where's our screen memory? So we're doing screen 1, which is here. So we use the proper name, comma Y, because Y is our row. Store that into and then NBA height. Right, so that's got our row. I'm hoping that's going to work. Am I going to put anything in front of it? Swap screens. No. Looks like we're okay. And then just add our X to it, because our X is going to be the column. So, but we can do that afterwards. So jump, add to, add column. So we'll jump to add column, which we haven't done yet. So we're going to work out screen 2, which is exactly the same as this. The only difference is we are looking at screen 2. And then add the column. Here we go. So we can add the column now. Don't need to write the code twice. So LDA screen location ADC so we'll do that up here. So we add X. And branch of carries clear, bypass, ink. If the carry's set, then we ink screen location 0 page +1. So we've worked out now our screen location. So our output is memory 0 page memory location that. So that's our output. We set that memory location with the with the screen location we want to look at. Too many red squiggly lines. So now we've done that, we can then get we can now get the material code. So we need that. So we need that. So we'll just set the label so we can use it. And what else do we need? The characters are always going to be the same for the map. We're assuming that we've only got one character set for the maps. So that should be okay. Alright, okay. So we're gonna, whoops, nope, not that. That's it. Initialize Y to be 0. Load the screen location. Gives us the character number. Transfer that into X, and then we'll use that. Or what have we called it? What have we called it? Char colors? Since when is that? Oh yeah, it is. I forgot. Right, so we load char colors, comma X. Now, char colors serves two purposes. Yeah. So, the top nibble is equal to the material, and the bottom nibble equals char color. So we need to do some work on this. So let's put the output parameter. So this is going to be accumulator equals character material code of that particular location. So we're going to load that. So the first thing we need to do, we need to get rid of the color. So we AND it with that. So effectively we get rid of the color. But I'm just wondering if we need to do that. No, we don't. That will do it. So let's say we've got a character, let's say we've got a material.
Oi, John, pay attention to chat.
Yes, mate. Yeah. Me and you were on the same wavelength. So if we've got a material code of that and a colour of that, as soon as we shift it, it'll become 01, 01, 0010. That's right, isn't it? Yep. And then 001, 01, 001. That's 2. 3, 1, 0, 0. And then the last one will do this. There we go. So we've effectively taken these 4 bytes, these 4 bits, and transferred them to there. So you don't need to do the AND, because I was going to AND it and then subtract a stupid number, which would have been wrong. So now the accumulator has the character material code, so we can return, because that's our output parameter, the character material code. So oh right, oh okay. That's a useful command, isn't it? Swap. Right. So that's a collision library. So we're not going to do the get material color yet. Yeah. Because we need to put on the screen where we think the where we think point is. Now I'm gonna have to make. Hey Gray, welcome. Right, I'm gonna load our. This is the one we're working on, yeah. So what I'm going to do is I'm gonna. Have we got? No, we haven't. Right, 225. Temporarily create another. And we're going to fill it. Or maybe not. Hang on, I've got a better idea. That'll do. So X marks the spot, right? So let's just save that. Let's export that. So we're going to try and put character 220 on the screen. So we need to work it out. And best thing to do is to show it on the screen. We're going to destroy the screen, but I don't care. Let's put it on the screen. In fact, we'll put it in the game loop. So game logic. We'll put it in here. So in the game loop, we're going to work out where quasi sprite is. Here we go. So we'll do it in there. We'll do it in this bit. So we need to include the code in quasi. Where's quasi? Here we go. So we need to include the code. Let's put it after here. There we go. So we'll put it in there. So we're loading Y with quasi sprite number. Quasi sprite number. Now we got a variable for that somewhere, haven't we? Anyway, multicolored sprite number. Shall we use that? No, we'll use that one. So that's loading the sprite number in. So we need to, and that is not animate, that is collision. So we need to JSR that. Work out the X and Y. And then once we've done that, JSR that dot work out the screen location, which gives us our location. So LDA hash, and it was character 225. 225 STA, store it in that place there, and we'll make sure Y is set back to 0. So this is just this is just to see. let's see if this works. Oh, I've got this horrible feeling I've just completely crunched it. Right, okay. Current screen. So I've got it in a namespace somewhere. Where is it? There we go. That's what we need. That's what we're missing. And it's in collision. Line 6. There we go. That's what we needed. Any more? Yep. I think that's it. What? All right then. Screen 1 line offset table number. Oh, I wonder if I'm using the wrong file. Oh yeah, here we go, it's here. Using the wrong file. Put them back in. So it's screen row low, screen row high. And then the other one is screen. There we go, that one. Thought I could have saved some bytes, but I can't be bothered. Right. What? It's in lib scroller, surely. Yeah. Come on guys, any reason why that... Oh, hang on. Oh, I see it. I see it. That's it. Right. Well, that's not working, is it? Do we need to set the colour? Doesn't seem to be putting any characters on the screen, does it? Oh, it is. Can you see? Ah, there it is. Hey Docster. Hey SP. Right, so we've got our but why is it not coming out? I did export it, didn't I? Did I export it? I did export it, didn't I? Let's do it again. Right, so it says that I've... It's changed, okay. Oh, it's just putting a black square. Sub's not working. Oh no! Right, we need to put... We need 225. That's the character, isn't it? Yeah, 22... Oh, 224... Pah! I have no idea what my other half's watching. Ah, there we go. There's our character. Oh, it's way far down. Oh, and it drops. So we're not quite right. Every now and then it's one up. So we're not quite working this out right. And I bet that's because the sprite doesn't start at 0, 0 on the screen. What's the border? What's the border for the sprite? Let's have a look. yeah. When we get the updated sprites, it'll get sorted. Right, what's... Oh, that's no good. I want to know what the border is. Is it 60? I know there's a website out there with all this stuff on it. Has anyone got that website where it shows you the dimensions of the screen? I don't seem to have it. Oh, dust cover. I've just been given dust cover. Is it .com? Well, it ain't .com, is it? Okay. Oh, dust layer. Okay. There we go. Right, where are we? Yeah, I've just been searching for dust cover, and I've got every type of dust cover think of. Oh dear. Right. Where are we? What are we looking for? Intro to sprites. I'm sure it's got to be in there somewhere. Where? Oh. Well, it ain't that. Hang on. I should know all this, but I think it's 60 b. Is it 60 by 60? Let's do that from. So we need to minus some values, don't we? There we go. That's what I'm after. There we go. Found it. Here we go. Is that what I'm after? Yeah, is this the one? That's the cycles, isn't it? Where's the one that... Oh, here we go. Oh, 29 down, 23 across. Really? So x minus 23, y minus 29. 0 to 29 is 30, isn't it? Right, let's do that. Ooh, interview. Good luck, mate. Right. So in this here, we're going to have to minus some numbers. So we'll do it there. We'll do it there. We'll do it here. Set carry. Yeah, good luck, mate. So subtract. So x is 24. Subtract 24. Right, so that does that. And then we need to do the same with y. So once it's stored it, we will subtract. And this one is 30. In fact, we don't need to load. Because we're already in A. Right, let's try that. Let's see if we get the square anywhere close to us. Oh, look at that! Right, so that's the edge of quasi. So we need ooh, what on earth is going on? It's better. Okay. So we need to right, so it's this area that we need to test. So we need to because at the moment, hang on. At the moment it's coming at the edge of the sprite. So we need to what? So that's 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Let's do it there. So that's another 8 to subtract off the X. Where are we? Plus 8. Oh, I may have gone the wrong way. Yeah, gone the wrong way. Bottom of the page. Oh yeah. Cheers, mate. I'm gonna bookmark that lot. Bookmark that. Thank you, mate. So, let's see. Have I got my maths right now? So I'm hoping the square well, one, it's too high up. So we need to four works better. What, you mean this? Okay. But we need to do it on here now. We need to. It needs to be pushed down. No, we're minusing, aren't we? Because we're subtracting. So if we want to drop it down, we don't subtract as much. That's it. Right. He's way off. Way off there. We need that brick. Look. We need it. We need that brick to come up. See, it's only just come up. I mean, it's all right that way, but because a sprite is more than a character, we've got to find the happy medium. Sorry, mate. Let's put it back to 8. Let's see what it looks like. You don't see the black foot. Well, we can change that temporarily. Let's just see. Logic. We can change that temporarily. We can make it grey. Let's make him grey. Here we go. Sprite, Jill. Here we go. High res sprite. We'll make it white so we can see where his foot is. So I've put it back to what I got, yeah? So there it is. So it's set straight away, it's gone and put it there. So if we move over, so it's gone to the next one, then to the next one, and if we move back this way, there. Is that, do you think it's there? Do you think we can get away with that? Yeah. Yeah, the only reason, right, okay, let me turn his resting animation back on, because I turned it off, didn't I? So we could see there we go, idle. Let's turn his animation back on.
Hi, John here. Another subscriber. Stay a while. Stay forever.
SP! Oh, thanks, mate. Oh! Raid? What do you mean raid? I need to make the voice more evil. I will. I will. I will try. I will try. I mean, but I've got to try. I've got to check something. I've got to check something. Oh, and it crashed. Rats. Rats, rats, rats. Oh. I'm gonna get this thing, so I'm gonna get this bot sorted if it kills me. Oh dear. I'd put code in to automatically update for a subscriber and it didn't work. It crashed. Andy's raid. Cheers for the raid, mate. I haven't done a voice for that yet. I ain't done a voice for that. I ought to. Right, let me add this new sub because it crashed. And it said 3. Right. You could tell it crashed, look, because my overlay's gone screwed up.
Hello, John here. Someone's hosting my stream. Oh, next thing they'll be nicking my code.
Right, refresh. Oh, don't tell me it's not working. Oh, no, there it is. SP, there you go. Akfin. Oh, the scroller's not working either. Oh, there we go. There you go, mate. I've tried to hook the bot, so when somebody subscribes, I'm trying to get it to update it automatically, but it, as you saw, it bombed. I'll have to look at that error message and see what it was all about. Ugh, I'm getting there. Anyway, back to this. Right. So we've got his right, so he's staying still now. So we can see. Oh, I think we can get away with that. I think we can get away with that. Because he is standing on it, isn't he? Shallan. Oh, now it's thrown a fit, hasn't it? Well, that works out. But then it throws a fit. I wonder if that's because of the delta. Ignore the red flash. That's just us putting the character on the screen. But it's gone all weird now. Oh, it works that going back, but doesn't work going forward. Oh, so he's gone up, hasn't he? He's gone up a row.
Oi, John, pay attention to chat.
I'm not taking into account the high bit. I thought I was. Thought I was. Because get screen X is supposed to get the coordinate on the screen. Which is here. So we're getting low, subtract the delta, yeah, I need to see what's coming out of this. Let's see. What can we do? Oh, we can do this, can't we? XI is a single byte, not 8 bytes. Yes, I know that. But in the sprite array, it's a byte, yeah, and then we convert it into a bit. That's why it's either 0 or 1. It won't be any. It shouldn't be any other number. But it's here where we are falling over. So I mean, this routine must work because this routine is used for the scroller. That determines where the scroll is. Yeah. Let's get rid of game logic. Because get X is relative on the screen. Yeah. As soon as it hits there, but it's gone here. Look. As soon as it started the scroll. It's like it's too many characters down. Yeah. Let's put a breakpoint here. And we will start quasi. We'll change his starting position to be we'll set it over there. Right, let's see. Let's do a debug on this. So it's going to be breaking an awful lot. So it's breaking already. Alright, so we clear the carry. So we're loading 0. So that's right. So F11. Oh, it's gonna be one of those things. There we go, he's moving now. So we're scrolling. There we go. Now he's crossed over. Now he's crossed over. So we should load 01, roll it into the carry, which it has. Oh, ED. 01 ED. That's not right. That's not right. That's not right. Right, okay. So the problem is not here. The problem is here. Here. Right. Here we go again. We'll wait until he's scrolling. Right. 2, 4, 3, 1. Excuse me. 2, 4, 3, 1. So these are the two numbers, right? So this is quasi there and quasi there. So hopefully we'll see what's going on. So we're doing one frame at a time. FD, FE, FF. Right, so we're scrolling now. 0, 1. So if we run through this now, set the carry, load 0, subtract R, so that's 2, that's right. Transfer that into X, set the carry. Oh dear. That's where we're going wrong. Silly Billy, silly me. Let's try that again. Let's take that off. That's better. That's better. Okay. Okay. Right. Let's just see how he is when it's not scrolled. Oh, I need to put him back, don't I? I need to put him back. Put him back. What was he? What was he? What was he at? Compare. Oh, no. Oh, just show me what was different compared to... Oh, rubbish. I think it was 140. That's roughly where it was, wasn't it? Right, so what happens when he doesn't scroll? That seems to... 60 or 160. Yeah. That seems to be okay that way. Well, I think we could get away with that. So this is determining what he's going to be running on or walking on. So I'm just thinking, see there, that has just appeared, yeah? That's just appeared. Let's just move him across. Right, so nothing's there, it hasn't evaluated it. Now it has. If that was an empty space, he would fall, because we've just determined that that is an empty space. So maybe we need to do the test over the two blocks. Oh, I don't know. How did Shallan do it? Did he test over two characters or just the one? Does anybody know? Did Shallan test over the two characters or just the one? Or did he test the character he was walking onto? So that means we've got to take consideration of direction. Ah, okay. Okay. See, my problem is, let's say, because we've just now evaluated that square there. And if that was a space, he would fall through that block, which would be, say, wall. So here, he should be still standing on there, even though he'd be halfway over. So we need to check both. So that means we need to know about we need to have direction. Or do we need to know about direction? Let's say we evaluate those two there. We move across, evaluates those two. On this side, we're on those two. Yeah, we would need to know about direction. Okay. We need to know about direction. Can I restart this? Let's restart this. I'll try and explain what I mean. Right, at the moment, he's sat on that block there. Yeah. But if we go in this direction, then it's that block and this block here. Yeah. Like so. But, let's run it again. But if he goes the other way, right, so he's, ignore that because that's just that. So it'd be this block and this block. So we need to know the direction. We'd need to know which direction he's going in. Because when he moves that way, this block that we've just evaluated, we would be evaluating this block here. And that's why we need to know about direction. But do we? Do we? Oh, thinking out loud here. We could make a queue. We could make, oh, okay. You have the pick and mix code. Right. We could have it as a queue. Yeah. So let me try and explain. Let me see if I can explain. So we have a queue of 2 bytes. Yeah. So as 1 byte goes in, we lose a byte. Yeah. So doesn't matter then which direction we go, because if we evaluate the character and then add it to the queue, it doesn't matter which direction you went. So it doesn't matter which direct, because the new character would be put at the head of the queue, and we would lose it, and then we just evaluate those 2 bytes for the floor. So if any one of them, yeah, that might work. Alright then. Let me make a note of that. So that might work, because it doesn't matter then if he goes in that direction, because the 2 bytes are in the queue. And if he goes back in that direction... Oh, hang on. That would have failed. Oh. We need to test for direction. We need to test for direction. How are we going to do that? Right, that's something we'll come back later. So we've now got it roughly about right. So it's detecting the character that it's on, that we're entering, yeah? What we need to do as well, we need to check these. So we've got to do direction anyway, because we need to check the characters up the side. So if, like here, let's say can't go past that, yeah? We've got to be able to check the character at the foot, let's just say at the foot. So here, we need to check there and there on this side. This will be interesting. Well, he didn't make that, did he? He didn't make those at all. Oh, he might have made that one. Yeah, he could have made that. Okay. So as well as the floor, we need to test the sides as well. So we need an array around him, so we can check what's going on. So it doesn't matter which way he goes, we evaluate all the squares. And then direction doesn't matter, because we can test when we're going in that direction, what's currently there. So let's try that. Let's try that. So do we need to do this? Yes, because we're putting in the sprite. We're putting in the sprite. So we might have to change the code. Yeah. I'll look at that. I'll look at that. I think they're bots. Oh, they're not. Oh, okay. Yeah, I'll sort it. I mean, I could sort it now, just run the lines out. But I'll sort it afterwards. So we need to change this. Need to change that. Okay. Hang on. Let me ram it out. Remember, it's a beta. It's still learning. Where are we? There it is. Right. That should stop it. That should stop that. Call it a spam bot. Yeah. Right, it shouldn't be notifying on a join now. Right, so we need to work out the XY of, so we need another one of these routines. So oh yeah, we're gonna call it something. I don't know what we're gonna call it, but it's gonna be called something. So this right, so this we need to change. So we need to have another one where but do we? Do we really? No. Let me I don't think we need to. I think we just need to mess around with this, with that. But we need to, instead of it being at the bottom of the sprite, we need it to be at the top. Or even halfway down. Let's do that. Hello, welcome. Right, so Y is the one we're messing around with. So let's put that back there, and let's do that. That should put the block underneath us now. Yeah. Now the problem with that is it's too low. Why is it too low? Yep. I understand now. So we subtract it to put it at, so we need to add so it should be at the top corner now. Now, is that at the top corner? Top corner is there. So that is where it is. Okay. But we need to move it that way. That's the X. So Docster's number. Now a bit further. There we go. So we don't need it that high. There we go. That's where we want it. No, it's not. No, we need to go a bit further down. Okay, we'll leave it where it was. Yeah, that's where we want it. So, bit of cheating going on here. So I'm going to simulate what I'm trying to do. Alright. So, LDY hash 3. So that's going to be 40, 41, 42. Right, this is, hoping this is in the right place. There we go. Not quite. Don't need that. Here we go. So this is where we would be checking, yeah? Right, let me start that again. So what we're going to do is we're going to have an array of 4, yeah? So we're going to evaluate this side and this side, no matter where he is, even if he's jumping, and evaluate this and this, where he's standing. And then, so once we've done that, so we could calculate that every frame, yeah? And then what we do is when we're moving, we know which direction he's going. So if he's going to go in this direction, we can test this memory location in our array and say, is that a wall? Is it a ladder? So on and so forth. In fact, I'm thinking we could do the 2 in between as well. In fact, that's what we'll do. So we'll have an array of 6, because we need to check the characters that he's on, because if he's on the ladder, we want him to be able to go up. So if he's not on a ladder, we can't go up. So we're going to have a set, an array of 6 that changes when he moves. Yeah. So there's always 6 characters in that array, and so the array is so it's always that around him. So we know what's here to stop him if it's a wall, we know what's here to stop him if it's another wall, and we know what's beneath him, because so if we have, say, block and then nothing, he should still be on there. But as soon as he moves away, then we'd probably get 2 nothings and he would fall, because then the physics engine would take over. Right, that sounds like a plan. So we work out what's around him for the 6, and then depending on what the user's asking to do, so if it's go right, we check this block and we check that he can walk. Yeah. In fact, we just check this block that he can walk. Doesn't matter what's underneath him, because if he walks off a plank, then he'll fall. And same if we go in this direction. All right, mate. We'll see you later. Yeah. Same with this direction. We test this. If it's a wall, we'll stop him, but if it's nothing, then we'll allow him to walk, and the physics engine will take care of the rest. I think that's a plan. So we need to implement this. We need to implement this. Right. So we're in here. So we need an array. Let's make an array. So what do we do? What do we do? Do we need to do it for all the sprites? We'll do it for Quasi at the moment, and then we'll expand it to others if we need to. So right, so 1, 2, 3, 4, 5, 6. So that's our array. So that's what's going to be around. So we just need to work it out. So we need another. We need basically this. That's what we need. So we need basically this. Quite a long label. Right. So input. So y equals a sprite number. So we come in with y, So we'll work out the Y and what the actual screen location is. That's my philosophy. So some of my variable names can be pretty long. Right. So instead of storing the value, we grab it. So we are going to start X with nothing. So X is So X is going to be our array index. So we are going to, let's see, so that means okay, let's do this. So that means this is so we use the first 4 for what's left, right and behind. Well, in fact, we'll do what's behind and right, and then what's beneath. There we go. So index, so we're going to load that, store it in that. So INX and INY, I suppose. So that's done that one. So that's 0, 1, 2, 3. So INX for that one, but now we're loading Y with 41. So do that. INX, INY. Right, that should have populated the array. Right, so we'll run this in C64 debugger, and we will see if the array has what we expect in it. Let's grab that. Put that there. So we're loading quasi sprite and then we're evaluating what's around it. Right, let's run this in debugger and then find out what memory locations we're looking for. Right, where's the byte? Dump. And collision library, here we go. 033436. I think that's probably our memory location for the array. Just check. Yes, it is. Right, 3436 is what we're looking for. So let's grab 3436. Here we go. So 0, 1, 2, 3, 4. So that's what it's evaluating. 3436. Oh no, 3436. 0, 1, 2, 3, 4, 5. There we go. That's our evaluation there. There we go. So we keep an eye on that. So if we move, so far nothing. Keep going. Right, we should start seeing characters turning up. There we go. So we have a 36, which is probably that character there. So if we move and get him to walk over it. There we go. So now the 36 is behind him and 37 is to there. Still 0, 0 there. And we have a 34 on the foot here. Okay, let's move him a bit further. Now, do we get no, we don't get that one. That's still 0. That's okay. Right, that spike should be changing. Oh, it won't be because we're animating, aren't we? Yeah, we're animating. Well, that seems to be working. That seems to be working. I'm just checking to see how the what's beneath when it comes to, right to the edge of this ladder, for example. Right, so we should have 2. There we go. OO, OD. And then it's 0, 0 right there. So technically it would fall there. I think that'll do. That'll do. So now we've got the characters. What we need to do is we need to work out the material number for it, which is here. Now we're loading from the screen and we're not going to do that anymore. We're now going to be loading from the array. And so what we need to do is we need to convert the what it's got from the screen into the material codes. So I think we don't do that. We send in, right, so accumulator will equal the character, and the accumulator is then the character code. So we don't need that. We don't need that. Just need that. So we can then do this. Load it, JSR that, store it. So we get the material code for each of the characters. Right, so I don't think we've got any material codes. Oops, I'm running the wrong one. F6. I don't think we've got any material codes in there. So 3436 should be still the same. It is. So that's what we're looking at. Oh. I just remembered. Yeah, we're destroying X. So we need to put STX var X. So we need to store X away because we're destroying X, and then load it back when it's so that's what we're doing there. Self mod code, store X to here, and then load it back in when it's finished. And the only reason I noticed that is because in C64 debugger only one cell was updating. So 3436, here we go. All the cells are now updating. So we should not get any numbers when we go over something. Yeah. So that's what we need to do now, is we need to put some material codes on it. So so now we need to work out of these 16 codes what all of them mean. Right. So we need a code to say it's danger, die, basically. We need a code for the wall. We need one for the ladder, one for a wall, so where am I going to put this comment? In here? Right. So 0, what would 0 be? Yeah, that's what I was thinking as well, SP, was to have one code that said you've got to stop. Yeah? So we'll have code 0, which means it's an empty cell, yeah? Solid block. Ladder. Danger. So let's say danger would be the fire, spikes, or anything else on there, I suppose. Anything else that is deemed to be poisonous or threat to life. There we go. So it would be definitely the fire and the spikes. We'll think about the other stuff later. So empty. Yeah, we'll, Stacy's done a good job. Look, he's got arrows. We've got two guys. So we got fireballs. We got two different types of guy. We have an arrow. Also, Sausage Toes was working on a Templar, which looked really good. So yeah, we're trying to have it like a throwback to the original, as well as trying to make it more up to date. So yeah, so what else? What else? So we need the ladder. We need something to say we're on a ladder. We need something to say where the background doesn't interface with us. Rope. What else is there? Yeah. We was on the same wavelength at the same time, mate. We'll start with those, yeah? We'll start with those. So we've got... So the solid blocks, we can define the solid blocks straight away. Right, so I think we do that. And so a solid block, we go like that, don't we? I wonder if we can do lots of them. What do we say ladder? 2. So this is the ladder. The bell, nothing. Right, fire. Now we don't need to worry about this fire. That's a 1 there, isn't it? Don't need to worry about this fire because the fire is down here. So that's the bell, this is the fire. There, so fire is danger, which is 3. 3. These are the spikes. Yeah, spike. Right, so these are spikes. So that's a 3, danger. We've got some more solid blocks there. We don't need to worry about those because that's taken from here. That's it. Everything else can be 0. Everything else can be 0. Right, let's just save. Right, I'm going to save as, and we'll give it today's date, which is the 16th. And then we'll export it. Right, so we'll change this lot. So 16th, 16th, 16th. Right, so that should have our character attributes. So if we C64 debugger this, we should start seeing character, the attributes coming in. Right, 3, 4, 3, 6. It's probably the same. We haven't done anything different. There we go, it's there. Right. Let's see what happens when we get to the ladder. So everything should be 0. Yeah, that's 0. Then the ladder should appear as a 3. No, it's a 2, isn't it? There we go. Ladder is 2, isn't it? Yes, ladder's 2. So look, the two parts of the array that look at beneath him is saying it's a ladder look. So then if we move across, now it's saying it's a solid block, and if we carry on moving, there you go, 3. So it's now saying, there's 3, it's now saying that this block is a danger block. It's 3. So if we stand in the middle of it, we should have, yeah, so we've got 3 and 3 behind us, and 0 and 0. Now beneath us, that's a problem. Right. We need to set these characters here. These characters need to be solid. Oh, no. They need to be danger, don't they? Oops, undo. That's it. These need to be danger. Yes. Or do we say the spikes are danger, but if he walks on them it's a solid block? No, we'll say it's danger. We'll say it's danger. And then what was the rope? That was 4, wasn't it? Yeah, rope was 4. Because the rope's there. And there. Come on. So 4, 4. So that's the rope. So we should be able to test the fire as well. Right, save that. Re-export it. Let's see. Right, 3. There we go. There's our array there. Right. Let's see if the spikes say it's danger when he's stood on. So that's the ladder. Solid block underneath him. Spikes. 3s all around. There we go. That's what we want to see. Right, so where's the fire? Here we go. So the fire should be underneath him. 3s underneath him, which they are. Now the ropes won't register because they're not low enough. Right, I think we've got the beginnings of our detection system. We are detecting everything that is around him. So we're checking for the 2 blocks below and the 4 blocks around where his feet are. So the block on the extremes plus the 2 blocks that he takes up. And we're getting the right numbers as well. Yep, we'll do that. You'll have to be quick. We'll have to be quick. Right, here we go. Let's see if we get a 4. Yep, we got 4s. Let's do that again. 4, 4, 4. Yep, we had 4s. So we've got the 4s coming up for rope. We just need to put it that routine, because the red area, the white goes way off because of the animation. So the red overruns. So we need to move. We need to move the logic. Here we go. So we need to move this logic somewhere else. Because it's overrunning. Could do it there in the purple section. Let's have a look at that. See if it overruns now. No, we're not getting any flashes now. Right, we're not getting any flashes now, so go back into C64 debugger. We'll boost the emulator on it. There we go. Right, let's get to the place. Just make sure it's still doing it, which is there. I ought to drop him, shouldn't I? Right, 2, 2, that's the ladder. Then he goes to 1, 1. Then we get the spikes, and he runs through the spikes. Then the fire. We'll back up, we'll do a jump. Through the 4s, yeah, lovely. Right, I think we've got the his environment evaluator working. We just need to now use that array when he's moving. We need to use the array to tell us what we can and can't do. Yeah. What's Jill doing up there? Thought she. Oh, I'm using a different map on her. Yeah, this is the 60. This is the 60 map. She should be over here. She should be up there. So now we've got the array that tells us what's around him. And so when we go left, say when we go left, if there's a wall there, we should stop. You know, you can't go left. We need to add a physics engine, so you know when there's nothing below him, it should automatically drop. Test for the danger areas. We're getting there. We're getting there. So I think that'll be the next stream, I think, where we'll start to use that array to determine how he's going to respond. We'll work out the physics engine as well. Yeah, we'll work out the physics engine as well to make to make him drop. So that can be we can start working on that on the next stream. So we'll do the easy stuff first. We'll drop him down so he interacts more with the environment, and see if we can get him to stop when it comes to a wall, in both directions, and also jumping as well. And we'll take it from there. I think that's a good step forward, that we've managed to evaluate his surroundings and get the codes that determine what we can do. Okay guys, well thank you very much for watching and helping me out. I think it's a good place to stop, and so I will put this in GitHub for you guys, the people that are helping out, and we will see what damage we can do on Wednesday. Alright, well thanks very much guys, and I will see you next time. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.